Alright, today we're going to be continuing what we were doing in our last class. We were talking about the recursive formula. So if we look at this, alright, we're given a pattern. It says at the beginning, after 1 minute, after 2 minutes, we'll describe the pattern you see in the sequence of the figures above. So take a minute, look at it, and try to figure it out. Pause it, and then start it when everybody's ready. Well, if you notice, it starts with 6, so starts with 6 blocks. And then adds 2 each minute. Adds 2 each minute. So it starts with 6 blocks and it's adding 2 each minute. So it's adding 2 and then adding 2 more, and so on and so forth. Assuming that the sequence continues in the same way, how many squares will there be after 3 minutes? Well, if this is 2, you're going to have your 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, and then you add 1 more, and then we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares. So there should be 12 squares. To complete our table, so after 1 minute, there were 8. After 2 minutes, there were 10. After 3 minutes, there were 12. After 4 minutes, there were 14. 5 minutes, 16. 6 minutes, 18. So what we're doing is we are adding 2 each time. So the minute increases by 1. So here's our minutes, which is n, increasing by 1. F of n is the squares, that's increasing by 2. So your recursive formula for this pattern, well, when we're talking about the recursive formula, there's always 2 parts to it. The first part, f of 0. Well, in this case, f of 0, or when n equals 0, there we started with 6 squares. So that tells us our starting point. Then the second part, well, what's happening with f of n? Well, f of n equals f of n minus 1, which is our previous step, and then to the previous step, we're adding 2. So if we think of that to get 1, we go back a step, so we go back and add 2. And then from 2, we go back, add 2. So that's our recursive formula. So f of n minus 1, which is the previous step, and then we're adding 2. The next question says, when would writing a recursive formula be productive? When would it not be? Take a minute to think about that in your groups. So when would it be productive? So it would be productive when looking for smaller numbers, like f of 2 or f of 4, something like that, some of those smaller numbers. When would it be not? When would it not? It would not be productive for numbers like f of 100. Question is why? Why would it not be good for f of 100? Because to get to 100, you're going to need to get 99. To get 99, you'll need 98. To get 98, you'll need 97. So because you will have to determine all of the previous values. So if you got to go all the way up to 100, you're not going to want to go from counting 1, 2, 3, 4. It's just going to take too long. But if you only need to get like f of 2 or f of 4, yeah, then the recursive formula would be beneficial because you can set up that table and you can just extend it to get up to 4. But if you need to go all the way up to 100, we're going to need something else. And that's where the next thing comes in. This is our explicit formula. So an explicit equation is a formula that allows for direct computation of any term in a sequence. So it's a direct computation, which means that you can directly get that number. And it's very similar to the other one, because we have our starting point, so which is f of 0, but then we add d times n. So the d is, once again, it's that common difference, and n is whatever step you're on. So how can we write this explicit equation for our pattern? Well, if we think about it, so if we have f of n equals f of 0 plus d times n, well, f of 0, we started at 6, so f of n equals 6, plus the common difference, well, we were adding 2 each time, so it's 2 times n. So f of n is going to equal to 6, which is our starting point, plus 2 times n. So if we want to figure out how many squares there will be after 200 minutes, well, what we know is that n is equal to 200 minutes. So if we have our equation, which is f of n equals 6 plus 2n, we plug in 200 for n. So we plug this in for the n, so f of 200. So at 200 minutes, 6 plus 2 times 200, which will give us 6 plus 400, which equals 406. So there will be 406 squares at 200 minutes. How many squares will there be after 10 minutes? Well, once again, we do the same thing. This time we know that n is equal to 10 minutes. So we have our equation f of n equals 6 plus 2n, and we plug in 10 for the n. So f of 10 equals 6 plus 2 times 10. Well, 2 times 10 is 20. 20 plus 6 is 26. So at 10 minutes, there'll be 26 squares. So f of 10 is equal to 26. Then it says, how many minutes will there be 74 squares? Well, now it gives us our answer. So it gives us f of n. So what we know here is that we're trying to figure out what n is. So we know that we have 74 is equal to f of n, because that's how many squares we have. So if we have our equation, I'm just going to plug in 74 for f of n. So now I get 74 equals 6 plus 2n. So 6 plus 2n. Subtract 6 from both sides. So now it's going back to solving our equation. So 74 minus 6 will give me 68 equals 2n. Divide by 2. And 34 will equal n. So now it's not 34 squares. N stands for minutes, so it's going to be 34 minutes. So after 34 minutes, we'll have 74 squares. And then we get down to number 10. How many squares will there be after p minutes? It sounds confusing at first, but if you just follow the formula, so what it says is n is going to be our p minutes. Just like before, n was our 10 minutes. So all we do is replace that. So it's basically f of p equals 6 plus 2p. So we're just replacing n with p. So we don't know what p minutes is. It could be 20 minutes. It could be 100 minutes. So we just replace n with our letter p. So now take a couple minutes, try to work on these next ones. So it's growing bacteria. When you're ready, just start the video back up. Alright, growing bacteria. Describe the pattern of change you see in the above sequence of bacteria. Well, if you notice, we start with 3. So we start with 3 bacteria. So it starts with 3. 1, 2, 3. And then after each minute, what's happening? Well, it goes from 3 to 6 to 12 to 24. So each one's doubling, or we're multiplying by 2. So it's doubling. Each bacteria is doubling. Or multiplying by 2. So doubling and multiplying by 2 mean the same thing. So assuming the growth of the bacteria continues in the same way, how many bacteria are there at 6 minutes? Well, so this is 3, this is 6, this is 12, this is 24, this is going to be 48 at 4 minutes. So at 5 minutes, there should be 96 bacteria. At 6 minutes, well, 96 times 2 is 192 bacteria. So there should be 192 bacteria. How do you know? Well, what we did is using our recursive equation, basically we know that f of 0 equals 3, f of 1 equals 6, f of 2 equals 12, f of 3 is 24, f of 4 is 48, f of 5 96, and f of 6 is 192. So we just used our recursive equation. We found each of these previous steps. And now, with this one, we can also set up an explicit equation. So just like the recursive, we have the same thing. So it's f of n equals f of 0 times r to the power of n. So it's r to the power of n because we're multiplying. So since we're multiplying, that's why we get r to the power of n, because if we just do r times r times r times r like this, we would know that this is 1, 2, 3, 4, 5, r to the 5th power. So we have to have the n as an exponent. So our equation now is going to be represented by f of n. Well, we start at, our start value is 3. So we start at 3. And the rate, well, if we look at this, it's doubling. So doubling is multiplying by 2. And now it's to the power of n because we don't know how many times we want to do it. We could do it 1 time. We could do it 20 times, which is actually what the next question asks us to do. So that's why we have this n, because we don't know how many times we want to multiply the 2. But we're doing 2 times 2 times 2 times 2 times 2. Now, how many bacteria are there at 20 minutes? Well, we have our equation, which is, well, first thing we do is we have to establish that n is equal to 20 minutes. So our equation is f of n equals 3 times 2 to the power of n. Now we replace n with 20, so f of 20 equals 3 times 2 to the power of 20. And that's going to be a really big number. Let me just get my graphing calculator out real quick. Okay, so what we will have to do, we're going to enter this in a graphing calculator because I don't think the little blue ones can do 2 to the 20th power. But so we do 3, and now our multiplication symbol, times, and we have 2. Now this button above the division sign, it's called our caret, that will raise 2 to the power of 20. So now we have 3 times 2 to the power of 20, and when we hit enter, we get 3,145,728. So f of 20 equals 3,145,728 bacteria. So after 20 minutes, there are 3,145,728 bacteria in our example. Now, if there are 384 bacteria, how many minutes have passed? So this tells us that f of n equals 384. So if we have our example here, so we have f of n equals 3 times 2 to the power of n. We take out n and we replace it with 384. So 384 equals 3 times 2 to the power of n. And now we can solve this. So we can do this one of two ways. We can use our graphing calculator. Well, we'll do it the way we learned before. So we want to get this 2n all by itself. Well, you could set up a table, and if you go back to, if we know that f of 6 is 192, we could continue that pattern. So we can make a table. So we had 0 was 6, no, 0 was 3, 1 was 6, 2 was 12, 3 was 24, 4 was 48, 5 was 96, 6 was 192, 7 is going to be 384. So to see how that's 7, when n is equal to 7, we have 384. So we know that n is equal to 7. The other way we could have did this, we could use a table, or we could have got 2 to the power of n all by itself. So if we divide by 3, because we're multiplying here, divide by 3, we're going to have 128 equals 2 to the power of n. Well, if we break down 128, it's going to be 2 to the 7th power equals 2 to the nth. Drop your bases, and 7 equals n. So that's going back to Unit 1, Topic 3, solving our exponential equations. So two ways to do it. Doesn't matter. We got 7. So after 7 minutes, we know our answer. Then the last question is, how many bacteria are there at p minutes? Well, once again, we're talking about minutes. So n is our minutes equals p. So if n equals p, we have our equation. F of n equals 3 times 2n. We take out n and put in p. So f of p equals 3 times 2 to the power of p. And that's our equation. So we're just replacing the variables. Alright, and there's 6 more problems, so work on those 6 problems, and we will go over that later. Alright.